Hello everyone, welcome to the Kubernetes series that we have started on YouTube. Okay, so today we are going to discuss about the volumes in Kubernetes. What is volume? So volume in a Kubernetes is like a storage unit, okay, which is attached to the pods. And what it allows is it allows your container which is running inside your pod to store and share the data, right? The data storing and sharing can be of your temporary way or it can be of persistent also, right? So now as you know now that okay, so volumes is nothing but a data sharing or a storage approach which is used in the Kubernetes, right? So there are five ways basically, right? If you can see here, the first one is the empty directory volume, second one is the host path volume, third one is the config map as a volume, fourth one is files share in Azure. Okay, in Azure, you can also use any other cloud service like GCP, AWS, or any other cloud service provider, right? So you can do file share as well. You can store the data on cloud. And the last, but the most important that we are going to discuss more in detail in maybe in this video or next video, that is persistent volume and a persistent volume claim. Okay, so now you know the number of or types of volumes we have. We have almost five types of volumes and how we use it. Okay, let's get started and understand from the first one is that is empty directory. Okay, so this one is empty directory here. Second one is the host path. Third one is config map, right? Fourth one is the file share. Okay, PV and PVC we are going to discuss in detail in the next video. Okay, so first thing, let's get started with the empty directory. Okay, so what is empty directory? As the name itself suggests, right? It is an empty but having some directory. Why it is called as a empty? Because when we delete the pod, right, due to some reason or it get failed or pod get crashed, right? So whatever the data sharing or storage is there into the directory that get emptied, right? It get deleted. That is why it is called empty directory. If a pods get crashed or or your container get crashed due to some reason it's getting newly created, pod is get newly created, in that case whatever the data will be stored or shared under the empty directory will be removed, right? So if you see this example, right, inside a pod, this is a pod, right? Inside a pod there are two containers, container A and container B. So you can create two different when you are container you are when you are creating container A, that is application A or application A, then you can mount it to some different empty directory. You can give the path and mount it to the empty directory. Similarly, when you are creating an application B or a container B, you can mount it to the another empty directory. There can also be a possible scenarios where you have multiple containers inside the pod and they are mounting it to a single empty directory path or a directory, okay, where your container A is doing a read write operation and let's suppose your container B is only doing the read operation. Your container your container B is only doing the read operation. So A can write the things and B can only read it. So this kind of design also you can create, right? So now let's get started here, and I mean we will understand more with the analogy as well, because I hope you have already understood what is this empty directory and how the design works. Okay, second thing I wanted to explain you, consider this as a pod, okay, and there are multiple containers running inside the pod. Okay, so how you have to understand the analogy here is, okay, so let's just assume that you are going or you are walking the inside the cubicle in your office, right? Let's say if you are going to the office and you are going to your cubicle, right? And in your cubicle, what you have noticed is that two or more people are on the same desk and they are sharing their cubicle and they are making the notes on that cubicle. What I'm trying to say is, let's say this is one table, okay, and every engineer is there or people are there who are using this desk and they're working together on this desk. They are creating, making notes here, right? They are doing notes and all, they are creating notes. And then when they are leaving, okay, so when the people are leaving from here, these notes are also, somebody is coming and they are doing the cleanup. Okay, so what I'm trying to say is when they everybody is leaving, somebody is coming and doing the cleanup of the notes as well, because they are doing the table cleanup or they are cleaning the whiteboards and all. So data is also getting lost at the same time, right? So I hope you have understand with this example that when a people, certain list of number of people came, they did a whiteboarding. When they have shared the data or they have shared the information, at the end of the session when they left, right, when they left as a container, you consider them as a pod. When they left the data, somebody came and they cleaned the infrastructure or they cleaned the data, whatever they have done on the whiteboarding. So that is called empty directory. This kind of behavior is called empty directory. Okay, so what else we can see here? Okay, so as I told here that this is an empty directory, and what kind of data we can store here? We should always save the temporary data, right? So we should always store here the temporary data. Point number one. Okay, so here we need to share only temporary data, because whenever the pod will be deleted, your data will be getting deleted from here. In what cases we should use it? We should use when your application is using caching. Okay, when your application is designed to have buffering between the containers, right? So in these all cases, containers. So in these all cases, we should definitely use, or we should recommend to use empty directory, right? So as we now I hope this is clear, and this is getting this path, how it is getting created is, it is on the var, then it should be on lib. Okay, then it is on kubelet, and then on the pod. Under the pod, it will be on certain location, right? So that's how we does basically this mapping and all. Okay, so this path is located inside the path is located inside the this path is located inside the pod. Okay, so this is an ephemeral storage. Okay, now let's discuss the second point here, which is nothing but we have to discuss about the host path now. Okay, so what host path does is, let's say you are inside the node, okay, and your pod is there, right? Your pod, or let's take the example of that office space only, right? So people will come. Okay, so let's say these are the list of people are coming. These people are coming, and instead of this time they are storing inside the pod. Okay, now this time what they will do is they will store outside the pod on the physical path of the node. Okay, so this will be physical host file system. Okay, so this time the the data will be stored on the physical host file system, on the pod, on the, not even, I mean, we should not say it as a physical, basically we should only say here host file system, right? So this is host file system. Let me erase it better and say it. Okay, so this should be your host file system. So this time This is stored into the data is stored in the host file system, and this host file system is present at the node level. Okay, so in the previous example, we have seen the data is present inside the pod. When it was deleted, the data was gone, right? And your application was referring only to the files which are present inside the directory. Now, in this case, where we are discussing about the host path, your application is stored on the host file system, which is stored at the node level. So what benefit we get here is, so assume in this case, your application is getting crashed, right? And your new application is getting created here. Okay. So that point of time, what will happen is, so let's say this is the new application which is getting created now. Okay. So what it will do is, this time it will again point to the host file system, which is present at the node level. Okay. And your application will be able to continue it and it will not fail, right? It is basically it is stored outside the pod. Okay. And it is stored on the nodes host file system, right? But now the problem here with this host file system is, so assume that there are multiple nodes running inside your cluster. Okay. If that will happen and this pod will get created inside some another node, this reference or your application is, if it is trying to point out to a host file system, let's say slash my host 1. Okay, in that point of time, and if your pods are getting created into inside, I mean in some another node, it will not be able to find out my host 1 because it is present into some different node. It is not at a cluster level, it is present at some different node, right? So at that point of time, your application will start crashing, right? So that's the pain of host file system. Okay, let me clean up now. I hope you have understood. Let me do the quick cleanup of this drawings. Okay, so what I try to explain, let me clearly call it out again. Let me call it out again here. So this needs a cleanup one more time. So what I try to explain you is, let's mimic this. Here we do Control C, Control V. Okay, so assume this is the another scenario. So let's say this is node 1. Okay, so this is your node 1. This is your node 2. And your application is required to go and point or get mounted to a file path or host path that is called node 1. Just take this. Okay, so your application is pointing to node 1, and let's assume this application or your pod got crashed due to some reason, and this pods A and B is getting created inside some another node, that is A dash B dash, which is of nothing but we are calling it as a node 2. Then it will point to node 2, right? It will go and point your application to node 2, to this file system, host file system. That point of time, your application will get crashed, isn't it? Why? Because your host file system itself got changed. The data was stored into this host file system, and now your application is running inside another node. Okay, so that is the problem with host file system. I will just do the cleanup and I will clear the screens also. Now let me use paint to clean this up. Okay, so I hope this is clear. I'm able to explain it well, this example, right? Okay, so that's the benefit of host file system. Now let me explain one more thing here. Okay, so we should understand one more thing. When a pod is getting created, right? In case of host file system, let's say this is pod is getting created. Okay, let's say this is the pod. When a pod is getting created, host path volume defined into the temp/demo. Let's say this, as we told, right? It is inside a node level. So it gets stored at path like slash temp slash demo. Let's say it is getting stored under this path. Okay, so Kubernetes mounts the node path, okay, to the container. So this gets mounted to the container. Okay, now container can read write on the file host system. And when a pod is getting deleted and a new pod will get created, okay, inside a single node, then it will be able to reference this path, right? So I hope you have understood this example and this flow basically. And now I should do this cleanup quickly. Right. Now this is done. We have also understood now about the host file system. Now our important topic, I mean, this we have already discussed, that is nothing but the config map. But let's discuss config map here as well. So in the case of config map, what happens is, or one more time, I can explain you about the analogy also with the analogy. Let's say if your people are coming inside your office for a meeting or they wanted to share some information. Last time they have shared on the table, right? But this time they will store this data inside some they will store into some Almira kind of thing and all, or in some drawer. So basically, if the application or your data is stored into some external thing, even if the person who is coming to clean up the things, he will not go and clean up the drawer or Almira, right? He'll not remove the data from there. So next time again you can come and you can again refer to that Almira or drawer to take your notes and all. So like that, host path will work. Now, what is this config map? Okay, so in case of config map, what happens is, so when you create a config map, it binds and it stores your data inside the master node. Okay, so there are two nodes we know, right? Worker node, master node. So in that case, etcd is going to come in picture. Okay, so your config map, what it will do is it will take the data, I mean your key value pair, it will be taken and it will be stored inside the master node in the etcd, under the etcd. And even if this pod is getting crashed and if it is getting recreated, okay, if it is getting recreated in that point of time, your new pod or new application is going to refer the master node and the data will be fetched properly. There will be no issue. Okay, so that's the benefit of having a config map. But you cannot, as you know already, that you cannot or store you should not store the secrets inside the config map. That's the that's the requirement basically. Okay, so this is clear. And what next we can discuss on this config map? So as so pods, if new pod will be created, it will be just it will go and access this from the main cluster. Okay, so this clears about the config map as well. Now next and last one is the file share. Okay, so when we discuss about the file shares, what happens is, so you assume that your application is running and you do not want it to store the data on the node level or a cluster level. You can take that application, right? And you can take the application and you can store the application at the cloud application. Okay, you can store it on AWS, GCP, Azure, right? Anywhere you can store it. Okay, so what happens is basically, let's take an example of Azure. You create a storage account. Under the storage account, you create a file share. Okay, you start uploading your files or application inside the file share, and then you simply do the mapping or volume mount on the file share from your application. So that is called file mapping or file mount as well. Okay, so when we have discussed about the config map, we have also discussed about the file mount as well. Okay, so this is all about the different kind of volumes we have in our system, and when we discussed about the Kubernetes, right? Now if we have to discuss about the another component, but let's say if you this file, if you can see, right? So how you will create the empty directory? Okay, so this is nothing but this is very simple. You are creating a pod. Okay, you are creating a pod, and you are giving a name of that pod as empty directory demo. Okay, you are using a busy box as in your image. You are doing some write command, hello, echo hello. You are saying hello on the, you're sending this message. Okay, and you are saying that volume mounts, you're creating a volume mount at this path. What is the path? This is slash data, right? And you are saying that, okay, I am, the spot will be, okay, so this is a container 2, this is container 1. Okay, there is two containers here. Basically, this is the second container. Okay, and this, in this case, there is nothing. Okay, here the name is writer. Okay, so this is going to perform the write operation, echo hello, and this is going to perform the read operation. Okay, we have not mentioned anything specifically here, but we should have mentioned here. It's okay. So this volume mounts, it is telling us where it is getting mounted. It is also getting mounted on the same location, that is slash data, right? So both the containers inside the pod are getting reference to path called data inside the container. Okay, and the volume name, the name of the volume which we are creating is called temporary storage, and this needs to be mentioned as empty directory. Definitely you have to mention in the curly braces or flower braces. Okay, so this is an example of empty directory. Whenever a pod is getting deleted, the data which is stored inside the data path, this is the mount path, it will get deleted as well. Okay, so if you can see here, we are saying echo hello and writing hello, and we are writing into the file called inside text.file.txt. This is the file. Okay, we are writing inside this file, but in this case we are doing cat operation on the file. So we are reading basically here. Okay, so this is writing, this is reading. That is why we are mentioning it as reader, writer, and reader. So these two pods, these two containers, or these two applications, clients, performing the operation on this path or this directory. Okay, so I hope you have understood here, and this is called volume mounts, where you wanted to mount your things. Okay, next thing here is we have discussed about the host path, right? Let's discuss about the host path as well. So in case of host path, let's see what is mentioned here. Kind is pod, name of the pod. This is same. Okay, under the spec, this is a container of image type busybox, and we are writing hello path under this message.text, and there is a sleep for 3600 seconds. Okay, and then what we are mentioning here is the volume mount. We are telling that okay, this needs to be mounted at this particular path slash host. Okay, and the type we are mentioning as directory or create. This is important in case of host path. Okay, so volume, the name of the volume is host path of type host. I mean, the name of the volume we are mentioning as host volume. You can mention anything, and since it is a host path, right? We have to mention the path, on which path you wanted to create the file on the node level, and what is the type. So type is directory or create. So you have to create every time, right? So if it is not there, it will create every time. So third one we have discussed about the file share. Okay, so basically you have to create a file share. You have to replace your IP address or actual IP of the NFS file share. So where you will replace here. Okay, so this is busybox, same thing. You are mounting on the your file share system. Okay, you are writing NFS test on this path. So this is all you can do at the Azure level also. Okay, and then you are giving the name of this volume as NFS volume, and it is getting you're saying that okay, server is the IP address and this is the path you have to write it. So this is how we create a file share. Config map is we have already discussed in the previous video in detail. So what config map is? So this is a pod where we are saying this name of the pod is config map demo. Okay, this is a busy box, again same image we are using, and we are reading it from etcd. I mean etc is by default directory under the config environment variables, right? So I'm volume mounting it. The name of my volume mount is config volume, which I'm creating here, and mounting path I'm giving here etc/config. This is my volume mount. Okay, so this is my config volume, and this is my config. This is the name of that volume is of config map type, and name is app config. So before you create this one, you need to create a config file as well. Okay, so before you run, first you need to do is you need to create a config map. You can do it either literals, from literals, imperative, declarative, anything you can follow. Okay, so you can create a config map and then you do this, right? So this marks the end of this uh, topic. Thank you, everyone. Thanks a lot for understanding. I hope this is clear, all the volumes topic. If not, just ping on the chat. We will help you on the discussions. Thank you, everyone. Have a great day.